Welcome to WION Podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore the discovery of a hidden supermassive black hole. Astronomers have discovered a black hole that contains 2 million times the mass of the Sun buried in gas and dust in the galaxy MRK 462. Black holes are extremely dense, with gravitational pulls so ferocious, not even light escapes. Cygnus X1 is the Milky Way's largest known stellar mass black hole and among the strongest X-ray sources seen from Earth. There are 3 categories of black holes. The smallest, like the unicorn, are so-called stellar mass black holes, formed by the gravitational collapse of a single star. There are gargantuan supermassive black holes, like the one at our galaxy's center, 26,000 light-years from Earth, which is 4 million times the Sun's mass. A few intermediate mass black holes also have been found with masses somewhere in between. MRK 462 contains only several hundred million stars, making it a dwarf galaxy. By contrast, our Milky Way is home to a few hundred billion stars. This is one of the first times that a heavily buried or obscured supermassive black hole has been found in a dwarf galaxy. The discovery of this supermassive black hole in a relatively small galaxy could help astronomers unravel the mystery surrounding how the very biggest black holes grow. They identified it using NASA's Chandra X-ray Observatory. This black hole in MRK 462 is among the smallest of the supermassive, or monster, black holes, said Jack Parker of Dartmouth College in New Hampshire, who led the study with colleague Ryan Hickox, also from Dartmouth. Black holes like this are notoriously hard to find. The unusually large intensity of high-energy X-rays compared to low-energy X-rays, along with comparisons to data at other wavelengths, indicates that the MRK 462 black hole is heavily obscured by gas. Because buried black holes are even harder to detect than exposed ones, finding this example might mean there are a lot more dwarf galaxies out there with similar black holes, said Hickox. This is important because it could help address a major question in astrophysics. How did black holes get so big so early in the universe? A large fraction of dwarf galaxies with supermassive black holes favors the idea that small black hole seeds from the earliest generation of stars grew astonishingly quickly to form the billion solar mass objects in the early universe. A smaller fraction would tip the scales to favor the idea that black holes began life weighing tens of thousands of suns. These expectations apply because the conditions necessary for the direct collapse from a giant cloud to a medium-sized black hole should be rare, so it is not expected that a large fraction of dwarf galaxies would contain supermassive black holes. Stellar mass black holes, on the other hand, are expected in every galaxy. We can't make strong conclusions from one example, but this result should encourage much more extensive searches for buried black holes in dwarf galaxies, said Parker. We're excited about what we might learn. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.